Assalamualaikum warahmatullahi wabarakatuh. And hi everyone, my name is Ahmad Hadi Nasrullah bin Abdul Rashid. So today I would like to talk about physics and aerodynamics in chapter 10 and chapter 11. So chapter 10, wave motion and sound. First of all, wave characteristics. A. Wavelength. Wavelength is the distance between two crests. So this point over here is called crest. This is crest and this is crest. So the length between two crests is called wavelength. B. Frequency. Frequency is the number of wave crests that pass a point every second. So from point here to point here, it's called frequency. So over here we got 1, 2, 3. So we got 3 hertz of frequency. C. Amplitude. Amplitude is the height of wave crest above the undisturbed position. So between crest and the undisturbed position we call amplitude. Alright, so D. Velocity. Velocity is the speed and direction that wave crest itself moving. So basically, velocity is the speed of wave. 10.7 Match number. The ratio of the speed of the airplane to the speed of sound in the same atmospheric condition. So how to calculate the Mach number? Using the formula speed of the aircraft over 10.8 resonance. Resonance is the natural frequency of a given object vibrates naturally or without the external force. Two objects have similar frequency. If one vibrates, the other can move too. Resonance is destructive force. Okay, as you can see over here, these two swings have the same frequency to this swing that played by this boy. So that's make if one vibrates, the other can move too. So this boy played the swing and the other two swing move same as the swing. Wave's property. The period of a wave is the time required for one complete wave to pass a given point, and thus F equals 1 over T with its unit hertz. The lambda, or wavelength, is the distance between adjacent wave crests. V equal to F lambda. The amplitude of a wave is the maximum displacement of the particle of the medium through which the wave passes on either side of their equilibrium position. The intensity of a wave is the rate at which it transports energy per unit area perpendicular to its direction of movement. So let's move on to the next chapter, chapter 11, optic light. Nature of light. Light waves are part of a group of electromagnetic waves or radiation that includes X-rays, ultraviolet, infrared rays, and radio wave. Second, light waves have a certain properties which are common. These are they travel through space at the speed of light. B. They obey the equation V equal to F lambda. Light dispersion. Within the light spectrum, there are 6 colors that can be readily identified: red, orange, yellow, green, blue, and violet, with indigo being difficult to distinguish. Sir Isaac Newton was the first person to explain this band of colors known as the spectrum using glass prism. Reflection. Reflection is the change in direction of a light wave when it bounces off boundary. There are 2 laws of reflection. First, the angle of incidence I over here is equal to the angle of reflection R over here. So these laws of reflection apply equally to curved and flat surface. Curved mirrors are of two types. First is concave, second is convex. Concave and convex mirrors. First, a concave mirror is a surface that is shaped in towards the middle and away from the observer. This is a concave mirror. It looks like a cave. Second, a convex surface is a surface where the center is shaped out towards the observer. It is in opposite direction to a concave surface. Refraction. A change in the direction of the light ray occurs when light ray move from one medium to another, example, air to water. This is called refraction. The direction in which they are refracted depends on whether they are moved into a more dense or less dense medium and respectively slow down or speed up. Light refractive index, or N, can be measured by using this formula: velocity of light in the vacuum over velocity of light in the substance. The reflective index N depends on the wavelength of the light. For an example, in a vacuum, light wave travels at 300,000 km per second, where in glass the velocity falls to 200,000 km per second. Snell's laws state that the ratio of the sine of the angle of incidence to the sine of the angle of diffraction at boundary of a two substance is always constant. The constants may be expressed as the refractive index of substance 2 with respect to substance 1, that is 1 and 2. Figure 10 shows that the angle theta 2 is increased until the emerging beam produces an angle of refraction theta 1 of 90 degrees. The angle of incidence on theta 2 in this case is then known as the critical angle. For figure 11, the angle theta 2 has been increased, which is greater than the critical angle C. As a result, the ray is totally reflected back into the same medium. This is known as total internal reflection. Lenses. There are two basic lenses. Convex lens, or also known as converging lens. The other one is concave lens, or known as diverging lens. The distance between two focal points and the optical center is known as the focal length and is given the symbol of f. It is on this value that the calculation of power is made. From this formula, 1 over frequency. How an image appears when using a lens can be obtained by drawing two of the following rays. A ray parallel to the principal axis, which is refracted through the focal point F. B. A ray through the optical center O, assuming no deviation caused by lens thickness. C. A ray through the focal point F, which is refracted parallel to the principal axis. Where the image is positioned and its nature, real or virtual, can be found by using the formula 1 over frequency equal to 1 over u plus 1 over v, which is u is the distance of object from the lens, and v is the distance of image from the lens. Next is electromagnetic waves. Electromagnetic waves lights consist of coupled electric and magnetic fields that vary periodically as they move through space. These fields are perpendicular to each other and to the directions of the wave. Hence, the waves are transverse. It requires no medium to travel and can transport energy. Radio waves, light waves, X-rays, and gamma rays are examples of electromagnetic waves. Light Characteristic of light. Apparent depth. An object submerged in water appears closer to the surface because the light leaving the surface bends away from the normal as it leaves. The object also seems shallower than it actually is. The ratio of apparent depth and true depth is equal to refraction index of liquid and refraction index of air. Lens. There are two basic types of lens, converging and diverging. Properties of lens. Focal length. The focal length of a thin lens is given by lens maker's equation. 1 over f equal in bracket n minus 1 in bracket 1 over r1 plus 1 over r2, where n equals to index of refraction of the lens material to the medium it is in. R1 and R2 equal to radius of curvature of two surfaces of the lens. A positive f corresponds to a converging lens and negative f to be a diverging lens.